Welcome to the second course in probability with examples using R. This is the second part in the series. The first part we studied discrete distributions. We covered them in detail. We understood their probability mass function, their expectation, variance. We understood how they relate to each other. If you have two random variables x and y, we understood if x has an effect on y via its probability mass function, a joint distribution, and we understood conditional distribution of x given y, and computed the variance, conditional expectation, and so on and so forth. We also began briefly discussing continuous distributions. So these are random variables that take values in an uncountable space, like the real line or 0, 1, and so on and so forth. We discussed briefly that the probability density function was the one that governed their behavior. In this course, we will begin with a brief review of continuous distributions. We'll start off from where we left off last semester. We will discuss their joint distribution and independence and conditional distributions. So that's the same way as in the discrete distribution course. So we'll start with bivariate ones, that is consider two random variables, and discuss how they interact with each other. We discuss independence, marginals, and also discuss their conditional distribution, density, and examples. Then we'll move on to functions of continuous random variables, which we also did in the discrete case. There we consider two random variables and discuss their sum or their quotient and so on and so forth. Here we will also generalize everything to more than one random variable. So for example, we will discuss how functions of x1 through xn behave when n is any number, and x1, x2, xn are either discrete or continuous. Then we'll move on to discussing the two key inequalities, Markov's inequality and Chebyshev's inequality. These inequalities govern probabilities of key events for random variables. They decide how a random variable differs from a fixed number by a certain amount, and we try to estimate the probabilities. They are very powerful inequalities, and we discuss them in detail. Then we'll move on to expectation and variance and covariance. So covariance understands how two random variables are dependent on each other or independent on each other. So it gives us an indicator. We will discuss the value of the indicator for the continuous random variable setting, and we'll also discuss conditional expectation and variance. We'll conclude this course with the three main theorems in probability. So one of them is the central limit theorem, the other is the strong law, and the weak law of large numbers. To do this, we need to know how to understand limiting behavior of random variables. So that's what we'll discuss, what's called almost sure convergence, or convergence in probability 1, convergence in probability, and conditional distribution. And throughout this whole course, we will use R to illustrate examples and simulate these conditional random variables. I hope you all enjoy the course. Thank you very much.